You're about to see something that's one of the most fascinating engineering feats I've ever seen. I've been down in the tunnel, although not recently. That machine, we call it Ladybird. Actually, the phase of the tunnel that we're building now is called the Blue Plains Tunnel. The first segment is from here, Blue Plains, all the way to the southern tip of Washington, went out underneath the Potomac and is going north under the Potomac, where it will go off to the right, to the east, up the Anacostia River. Completing its first leg of this journey, the Blue Plains Tunnel at around Nationals Ballpark, where we have main or significant pump stations, and Poplar Point. A second phase of this huge tunnel will start all the way at RFK Stadium and actually come south on the Anacostia. And like trains meeting 200 years ago, they will meet together at near the Nationals Ballpark. That'll be the second phase. The third phase of the tunnel will start at RFK Stadium and tunnel into the city to where LaDroit Park, Bloomingdale, that historic flooding has happened. In total length, the tunnel will be 13 miles long. We are now up underneath the Potomac. I'd have to actually check how far we've gotten today. It's working 24 hours a day, 6 days a week. So that huge, the machine is just massive in its size, as you will see when you go down there. It's more than a football field in length. So if you just were looking at the entire field, the entire machine is longer than that, and another third. And it's 26 feet in diameter. So you take 2 basketball hoops and pile them on top of each other, and you still got another 6 feet to go before you reach the height of this machine. So it's just a mammoth piece of machinery. And it's an incredibly engineered, self-contained unit. The way it works, as you will see when you go out down there, is there's part of the machine is putting in these precast, tight-fitting concrete. I mean, they're 1.5 feet thick, going into the walls of the tunnel as it's being drilled. Obviously, the very front piece of the tunnel, of the side of the tunnel, has a lip on it where the next piece hasn't been put yet. The machine itself pushes hydraulic presses onto that lip of what's been put and pushes itself forward using that as its backbone. And then when the hydraulic pushes as far as it can, they'll pull back. Now there's this space. The next pieces get put in. And so it's pushing itself sort of like an inchworm. It's moving in segments forward by the width of one of the pieces of the tunnel, which are all precast. You'll see them piled up outside the hole. Hole is not quite the right word. It's enormous, 10 stories down. It's huge. The precast pieces are brought forward on this train that comes forward into the machine. So there's always precast pieces coming forward into the machine. And then there's a conveyor belt that has been built that follows the machine behind it to take out all the mud and the rock that's being drilled from the front of the drill machine. So there's that's continually moving back and forth as the machine goes forward. And you'll probably get to stand and see the control room, which is sort of like driving this very slow moving but gigantic, it's like the Titanic underground, where it shows exactly the direction and how it makes a very slow curve to take this turn that's going to go up the Anacostia. It's an incredible undertaking. And as I said, it's the first third of 3 segments, the biggest of which is the third of them, which is the one that goes all the way into Northeast Washington. The combination of these tunnels, when all put together, is going to capture so much overflow of rainwater and sewage that otherwise would have gone untreated to the Anacostia River, that we had to pick an average hydrologic year. So there's an average of 3 years, relatively high rainfall because we wanted to overprotect. 98% of what today in a rainstorm would fill up in these combined pipes that currently exist and aren't big enough, and instead rather when the pipe fills and there's no more space, it overflows to the river. 98% of that will go down huge drop shafts, be captured in this mammoth tunnel, and the tunnel will convey it all the way down to Blue Plains, where something we're going to build now that the machine is going on its way up. The next extraordinarily complex and fascinating parts of the project is there's a double, looks like the figure 8 of 2 tunnels that are going down into the ground, one of which now has the tunnel going up the Potomac. Those 2 tunnels, one is for screening. So imagine what's happening in a storm. All this rainfall hits the street. It goes down a storm drain. From the storm drain, it's connected into the same sewer pipe that sewage is in. Tremendous amounts of flow hits that pipe. The pipe fills, all the water overflows and spills down a drop shaft into this huge tunnel underground. And it comes down like a torrent, underground river, down to Blue Plains. So first we have to stop the flow. It's coming down with incredible velocity and force. Then once it's stopped, we have to screen it because there's a lot of refuse in it. We can't get it through the pumps to pump it 10 stories up to the. So there's a screening operation down there with these long pulley bucket systems that take out the refuse that we're taking out. Then some of the largest turbines that you can, and pumps that you can imagine, the amount of power it takes to lift millions of gallons of combined stormwater and sewage all the way to the surface are huge. And that's all being built underground inside the shaft. Then on top of the shaft, at the surface, we're building a treatment plant that will help treat all of what we're pumping to the surface. So it's an incredibly complex engineering job, of which you'll see the big tunnels going down, which is where there'll now be a pump station built in there, going 16 stories ultimately. And you'll see the tunnel going under the ground. What you haven't really seen yet is what's going to be built right on top of it, which is on top of that, a whole new treatment plant will be built.